Greetings to all of you. The session is regarding intermediate chemistry, where this will be fetching for your international entrance and competitive exams as well. India is conducting JEE Advanced and JEE Mains for BTech entrance, BTech admissions throughout India. In addition to that one, NEET will be conducted, that is the medical entrance examination across India. And the Telangana, Andhra Pradesh government are conducting MCET examination for the admission into BTech stream. Again, it is the technical domain. In addition to this one, if you're aspiring for any competitive examination conducted by the government organizations where general studies question paper is available, in that general science content will be there, that the session what we are discussing is very much fetching for that kind of preparation as well. Let's enter into our today's session. We will start with the Nobel Prize in the field of chemistry. In the year 2006 was awarded for Roger D. Kornberg for his studies of the molecular basis of eukaryote transcription, right? So this is the one where 2006 Nobel Prize, this is the prestigious prize all across the world, is accorded to the person Roger D. Kornberg. He carried the studies on molecular basis of eukaryote transcription. Transcription is the kind of process which is carried for protein synthesis on the genetic level, right? So for that studies, he was accorded with the Nobel Prize. He's the scientist who accorded with the Nobel Prize, Roger D. Kornberg. He alone contributed, one by one means he alone contributed for 2006 Chemistry Nobel Prize. Let's see the brief info regarding this scientist. The Royal Swedish Academy of Sciences is awarding this Nobel Prize in the field of chemistry. For the year 2006, it is given to Roger D. Kornberg, Stanford University, CA, USA, United States of America, for his studies of the molecular basis of eukaryote transcription. So based on this transcription studies, he was accorded for this Nobel Prize in the year 2006 in the field of chemistry. Right. Let's see that how the process is carried, what research he was carried, and how it was accorded. In order for our bodies to make use of information stored in the genes, everybody aware that genetic code, genetic matter, whatever present in the human being or any living organism is the important matter which imparts the properties to that particular organism, right? A copy of must first be made and transferred to other parts of the cells. Whatever genetic matter is there, that to be copied and that to be replicated, right? There is there it is used as a instruction for the protein production, right? So by using that one, we are going to synthesize the proteins. This is the protein synthesis. In that their turn actually construct the organism and it's a function. Okay, so this genetic matter is responsible for the construction of the organisms and their functions will be regulated under this mechanism, right? The copying process is called transcription, right? Copying process means what? So already existing information can be replicated, can be taken further, multiplied by means of copying process, that can be mentioned as a transcription. Roger Kornberg was the first creator of the actual picture of how transcription works. On the molecular level is important group of organisms called eukaryotes, right? Especially the process called transcription was implemented at a molecular level in eukaryote organisms. Organisms are categorized into two types, prokaryotes and eukaryotes. Eukaryotes are nothing but well-defined nucleus containing organisms are classed as eukaryote species. Prokaryotes also present where that extent defined nucleus may not be present, right? Mammals like ourselves are included in this group, and ordinary yeast and words, all these mammals are the part of these eukaryotes. Transcription is necessary for all the life. This makes a detailed description of the mechanism. Roger Kornberg provides exactly the kind of most important chemical discovery, right? So that it was accorded with the esteemed Nobel Prize in the field of chemistry for his process called transcription at molecular level. If the transcription stops, what happened? What is the role of this transcription in the living organism? Transcription is nothing but copying and replication of the same kind of genes throughout the organism, throughout the body of that particular living organism, right? If that transcription gets stopped, genetic information no longer transferred. Okay, whatever genetic matter is there, that will not be extended further, no longer transferred into different parts of the body, since it is no longer renewed. So renewal of the process may not be possible. So that organism may not find the kind of a new thing, new genetic matter over there. So that organism may not grow further, and subsequently it will die in very few days, right? This is what happens in the case of poisoning. So whatever kind of toxins are entered into the organism, so that it will stop the process called transcription, so that genetic matter extension may not be possible, right? And the same will be carried for the patients who are suffering with the cancer, heart diseases, and kind of inflammations as well. In all these process, transcription fails to perform, so that we can't extend the genetic matter to all over the body organisms every time. So how the water is flowing, how we are watering the plant every day, then only plant will grow and the plant will be flourished, right? So if we stop watering, what happens? That will become dull slowly, and for few days it will survive. So it will no longer alive without any water supply, right? In the same manner, this is also the kind of transcription is required to be continued, so that we can extend the genetic matter all over the organisms, so that flourishing of that particular organisms are possible. Whenever transcription gets stopped, further growth of organism may not be possible. So retardation of the growth is possible, so that the slow decay of organism is possible. So this is the way how important the process is, and what way this transcription was identified at the molecular level, especially in the eukaryotes, done by this Roger D. Conwell. For this, he was accorded with the Nobel Prize in the field of chemistry. Let's move on to another question. This is the way how the transcription is possible, and further translated gives rise to the protein. Polypeptide is nothing but protein only, right? So this is the entire diagrammatic representation of transcription, subsequently translation. Transcription was taken on this genetic matter called DNA. All these nucleic acids are present over there, and they will read on this RNA. DNA stands for deoxynucleic acid, deoxyribonucleic acid, and RNA stands for ribonucleic acid. This is the way transcription got carried over, and after this transcription, the transcript further utilized for the synthesis of polypeptide. This the new strand generation. So in this DNA, new strand will be generated that is copied. Actually, that is copied. That copied one is said to be a transcripted. Transcript is nothing but a copied one, and translation is nothing but that will be shifted to any other kind of language. Another codon triplets will be generated over there. That is called translation process, so that we will get polypeptide linkage over there. So this is the way protein synthesis get carried at a genetic level. So let's move on to another question, which was taken from Cambridge Assessment International Education. Here you can find so many components. Let me read all the chemical components whichever available. So based on these chemical components, we have few questions, 3 questions to be answered. Let me read all these. Calcium oxide, ethene, chloride, copper +2 dipositive cation, hydrogen gas, helium, noble gas, K plus is nothing but potassium monopositive ion. N2 means molecular nitrogen. Na positive means sodium monopositive ion. Sulfur dioxide gas. These many chemical components are provided. From these chemical components, we have to depict the questions and subsequent answers to be drawn. Answer the following questions using these symbols or formulae. Each symbol or formulae may be used once, more than once, or not at all, right? So here, these formulas can be utilized for answering these questions. Let me go with the question number one. State which symbol or formula represent a compound produced by the thermal decomposition of calcium carbonate, which is the product of thermal decomposition of calcium carbonate. Calcium carbonate simply represented as CaCO3. If CaCO3 got decomposed, what product you can notice from these to be answered? That is question number one. Move on to second one. A positive ion that gives a blue-green colored flame test, which is able to give the blue-green colored flame test to be depicted from this list. In either one, an element used as a fuel, which is efficient fuel in this entire list of chemical components to be identified. Let me go with the answers of all these questions. Right. Question one to be answered like this. A decomposition of calcium carbonate. Whenever heated, calcium carbonate got heated, there are the products like calcium oxide and carbon dioxide. Carbon dioxide will be a gas and calcium oxide will be a product what we require over there, right? If you observe this calcium oxide, you can notice over there, so that calcium oxide is the right answer. Can you find carbon dioxide over here? Carbon dioxide may not be present. One of the product is provided, that is CaO. Calcium oxide is there. So that this will be the correct answer for question one. Move on to question two. A positive ion that gives the blue-green color on the flame test. So whenever flame test got carried, green-blue color at the center is provided for the copper. Copper is the metal. All the metals are able to give the characteristic flame test reaction. If you go with the barium, apple green color will be appeared. Potassium gives rise to the pink violet in the color, and lithium crimson red color will be provided. Blue green color at the center for copper will be generated. This is the way question number two got answered. An element used in the fuel is. So here hydrogen fuel of the future, so that hydrogen is the kind of most efficient gaseous component, so that it is used in the fuel for the future. This is the way we can answer all three questions from the list given. Let's move on to another question. Question number three, that is taken from the JEE Advanced 2016 paper 1 on complete hydrogenation natural rubber produces. Natural rubber is a kind of polyisoprene. Polyisoprene is nothing but 2-methyl 1,3-butadiene can polymerize, giving rise to the polymer you can notice over here. That is this is a kind of natural rubber. NR denotes what? Natural rubber. Natural rubber, first of all, we are going with the hydrogenation process. Wherever double bond is there, we are going to add the hydrogen, so that will be converted into a saturated one. And the further generation of this will be possible by taking two different components over there. One is said to be propylene, in either is ethene. In order to get this product, we can take the starting materials. One will be propylene, in either will be the ethene molecule. So let's find the ethylene propylene copolymer is available at option number A. Option number A is the correct answer for the question number 3. A complete hydrogenation of the natural rubber as producing ethylene propylene copolymer, right? So this is the way question number 3 got answered, and move on to question number 4. The product of the following reaction sequence is here. The starting material taken as an aniline. Acetic anhydride pyridine will be treated. KBrO3 potassium bromate HBr will be treated. Water will be added under heat conditions, and NaNO2 called sodium nitrite will be added, HCl. Copper HBr will be added. These many components, if added, this aniline will be transformed into a dibromobenzene. Dibromobenzene is the right answer for this question. Let me go with a series of reactions over there. Initially, aniline will be taken, added with the acetic anhydride in the presence of pyridine so that N-acylation got carried. N-acylated aniline is the product over there, KBrO3HBr. If treated electrophilic, bromination is possible, especially at para position. That's purely because all of the positions are completely occupied by the steric hindrance, so that only para position is suitable for the electrophilic substitution reaction. Later on, what hydrolysis got carried under acidified conditions, so that acyl group will be removed, so that free aniline. This is called deprotection, and you can observe amino moiety over there. And further, NaNO to HCl is called diazotization process, purely carried at lower temperature. 0 to 5 degrees are required. On Kelvin scale, 273 to 278 Kelvin temperature is suitable. So that free amine got converted into diazonium salt. Diazonium salt will be generated upon treating with metallic copper and HBr, so that entire deamination process got carried and a bromo will be substituted over there. Already existing bromo and new bromo got received, so that dibromobenzene is the final product for this question. This is the way question number 4 got answered, and the expected product will be option B. Dibromobenzene. 1,4 dibromobenzene is the exact IUPAC name of the compound. Move on to another question, question number 5. The correct increasing order of electronegativity is to be depicted. రుణవిద్యుదాత్మకత పెరిగే క్రమాన్ని మనం ఐడెంటిఫై చేయాలి. Boron, carbon, sulfur, and chlorine are provided, and the exact answer for this increasing order of electronegativity will be boron to carbon, carbon to sulfur, sulfur to chloro will be increased in this order. Exact answer is option number 1. For this option 1, we have to go for the explanation part. And this, we have the periodic trend over there. Periodic trend, especially in the electronegativity. If we take the period from the left to right, gradually electronegativity values got increased. If we are descending from top to bottom in the group, electronegativity values gradually decreasing, right? So that if you go with boron, it is indicated as 0.8. The carbon is given by 2.0, and the nitrogen is given by around nitrogen value is fluorine on Mulliken scale, fluorine electronegativity value is 4, oxygen will be 3.5, nitrogen will be 3, and carbon will be 2.5, boron will be 2. This is the way we can answer, so that boron will be least in comparison to the carbon, and the sulfur will be more in comparison to the carbon, and chlorine will be the highest one in this series. So that for question number 5, option number 1 is the correct answer. Anyway, from this we can, first of all, we have to identify from all 4 options. First of all, we have to identify among all the elements whichever provided, halogens are having highest electronegativity values. Fluorine electronegativity value will be 4, and later on chlorine will be there, right? So that you can go with the chlorine containing options. After getting chlorine containing options, next element either carbon or sulfur. If you want to compare the carbon and sulfur, here carbon electronegativity is 2.5. And in case of this one, 3.5, 3 will be, around 3 will be there for the sulfur. Obviously, sulfur will be highest in comparison to the carbon. That's the reason why boron will be least with 2 on the Mulliken scale, and the carbon, sulfur, and the chlorine will be the highest. This is the way option 1 will be the correct answer for question number 5. Let's move on to last question of the session. The alkaline earth metal sulfate, which has its hydration enthalpy greater than its lattice energy, is the alkaline earth metal sulfate, which has its hydration enthalpy greater than its lattice energy. క్షార మృత్తిక లోహ సల్ఫేట్లలో దేని యొక్క ఆక్సీకరణ ఎంథాల్పీ జాలక ఎంథాల్పీ కంటే ఎక్కువగా ఉంది? దట్ టు బి ఆన్సర్డ్. ద కరెక్ట్ ఆన్సర్ ఈస్ బెరిలియం సల్ఫేట్. Here, first of all, we have to compare hydration enthalpy and lattice enthalpy. any element or any compound contains highest hydration enthalpy will be the least in the size. Smaller atoms are having highest hydration enthalpy. Obviously, strontium, calcium, barium, beryllium. The smallest one will be beryllium, so that largest hydration enthalpy will be there. So in that regard, we can go with the answer. So let me give the detailed answer for the question. If you read the question carefully, you are indirectly asked to get the solubility of the given metal sulfates. Here, the expected answer is beryllium sulfate. This is because hydration enthalpy of the cation decreases as we down the group, because as the size increases, hydration enthalpy values get decreased. But lattice energy values not decreasing that extent, so that hydration enthalpy values are decreasing, but not lattice energy values that extent. So that hence the solubility of alkaline earth metal sulfates decreases as we descending down the group. So the expected answer, highest hydration enthalpy, but not that extent of lattice energy, is given for beryllium sulfate. For question number 6, option number 1 will be the correct answer. By this, we entirely completed the session where we covered the different aspects included with the Nobel Prize of the chemistry, and also various chemical component list is provided, so that the based on questions are given. And the next day we gone through the previous JEE advanced question papers and the MCET examination question papers also discussed as well. And there is a question for the session to be commented, to be answered by the commenting of this session. The question for the session is, if you are taking metal sodium and also metal potassium, what will be the colors of their flame test? That can be mentioned in the comment box for the session. I'm requesting you to like the channel and comment which part is really important and interesting for your preparation, and share with us parents who are more serious about the examination. Subscribe the channel so that we will go with the new content in the near future. Thank you one and all. Thank you for listening.